So in today's video, we are going to try to call our Oracle, or basically the smart contract or the program where we write the price data to in another smart contract. So it becomes basically a real Oracle because currently we are just writing data to the program, and we now need to read the data in another smart contract, which then can have some logic based on the Oracle data. Let's see. So this is currently our Oracle. We basically initialize a new PDA and then have an update function where we just write data to it. Is this the latest version? Yeah, okay. The name is the pair or the ticker of, in our case, it's just, we currently have just one PDA or one price feed feeding into the Oracle, and that's Bitcoin USDT. Let's see, is our bundle. So we have I have built a simple UI here. That's the WebSocket price stream of Bitcoin USDT from Binance, and we can just start the Oracle. This will write the latest price to the smart contract 5 times and then stops again, just for like playing around and seeing how it works. We can check the transaction logs. Then we see we have our Oracle CR65. That's our Oracle program. That's our wallet, I guess, and that's the PDA then, right? I don't log it here, but that has to be the PDA. Anyways, in the instruction logs, we see update price, and that's the price multiplied by 1000, I think, just to have the, how's it called, the decimals in there as well. Right, so we have like data written to this PDA, and now we want to create a new smart contract where we read from it. And since I have never called or integrated another smart contract or another program or called another program from a program, and we see how we do it in our fifth example, where we just loaded the price feed from account info, but I haven't written that function by myself. That's just imported. But this basically is a program on its own, and that's the only function like that. Wait. So we feed it the SolUSD price account, which is an account info. And then we use the SolUSD price account here, and this returns us the price feed data. So let's look what this does. Can't I? I want to see the definition of it. Seems like I can't go into libraries. Then Another question that I have is, was it that good to initialize the seeds with the user public key, but in theory reading from that PDA anybody should be able to read from it. Just writing, you would need the Okay, let's see. Call anchor. Call another program. Cross-program invocations, yes. Okay. Just like let's see. Let's just create. Is this how we create a file? No, this is how we create a project. This is how we create a file. Let's just call it master, like in the example, and then just leave it empty, I guess, because we want a new key on deployment. And now let's call it pull data, pull data, pull data. And this is like set data. Why do we need set data? Because we are setting data. I think this is something. We don't need for now. I think creating custom seeds was not that clever. Let's just import the program. It's my Oracle and here it's Puppet. Let's see. Use lib program my oracle. And then here we have lib. And then let's see what's data. Data is just our struct, our data struct. And for us, that's data store. So we import data store. Puppet is our it's called Oracle. PDA, and that's our Oracle program. And that's of course not Puppet, it's my Oracle. So this creates a new context and sets data. This is nothing we need for now. Let's just message test. Let's see what this is. So, I think we have to change the mutable here to include the custom seeds as well, but that's what I wanna check. So this has built lib.rs. We haven't built master. How can I build master? Master has the same program ID now. I don't want this. So here's FG6. Yeah, and this has another ID. So to also add the line programs.localnet section. So to pull strings, we need the program and the PDA we wanna like pull data from. I'm not quite sure if I can just create the TOML files in the playground. This program my Oracle, yeah. Let's close this, maybe we can build now. Okay, seems like a playground is only like to build one program, and we would need to do this in a new playground project, but then I can't import this. I mean, some of this makes sense and I get it, but this is Solana native. I want to do it with Rust. So we have a system program. System program is not. Final review. Okay, this is advanced. So just like 27 minutes on Zyre. Would prefer to watch
I am
this,
Anatoly Yakovenko, the CEO of Solana. Today marks a historic day.
Focus! Hello and welcome to another Solana tutorial. Today we're gonna talk about Anchor program development. That's module 5, lesson 4, CPIs in Anchor. Also errors.
Okay, so one day I just wanted to go through the SolDev course and basically every day one lesson, but I started with it, and some of the lessons are just outdated and don't work anymore, so it's really annoying to go through it. But it would be quite helpful since we learn here how to just call another
So
program.
let's jump
Exactly
right
what we
in.
want to do.
Some people wanted me to be smaller, but I kind of like this. I kind of like having my hands all over, so I'm just gonna continue like this. Objectives, let's look at this from another side. Today we're gonna do cross-program invocations, CPIs, from an Anchor program. We use the CPI feature to generate helper functions that allow us to easily do that. And we will also use the invoke and invoke signed, the standard Solana way how to do CPIs if we don't have any helper functions from Anchor. And then the error code attribute macro, somewhat challenging to build all of that. You need to manually build the instruction and then put in all the account infos, and that is a little difficult, especially if you're just starting out developing on Solana. Anchor makes that easier though, especially if we just invoke another Anchor program, because then we can use this CPI context and do an Anchor CPI. Cool, so let's look into that. Cross-program invocations, CPIs with Anchor. So because I haven't said that enough, a CPI is when our program calls another program, or a CPI is when a program calls another program. Hashtag composability. And we can still use invoke and invoke signed, but Anchor has this CPI context to do CPIs with. So the Anchor way to do CPIs is with this CPI context. So essentially what you gotta do is create an instance of this CPI context. And the cool thing is this CPI context is very similar to the normal context that we know from a normal instruction. Let me show you in the program that we had. Remember this? This was our first Anchor program, and here we get the context, and that context has accounts, bumps, program ID, remaining accounts. So essentially accounts, it knows which program ID, and that thing is similar to a CPI context that we will build. So the CPI context has accounts, remaining accounts, program, and signer seeds. So it doesn't have the bumps, but it will have the signer seeds that we use for signing, and that also kind of contains the bumps indirectly. That's what that would look like. In the type, accounts are, so for this T, two account matters and two account infos must exist. The list of accounts required for the instruction being invoked. So we need both the account matters and the account infos for these accounts, for those accounts, if we would say it grammatically correct. Remaining accounts, hey, if I would have read that tutorial, say, half a month ago, I could have done a much better job in the actual CPI of the CNFT example. Maybe I still want to do an update on that. Remember how we made it very difficult for ourselves because we didn't manage to get the remaining accounts into the CPI context? Yes, it just contains the remaining accounts. I want to have a look at this now. Because here I did a normal invoke sign because I didn't manage to put the remaining accounts in my attempt 1, this transfer. So the CPI context new with signer, and here it has remaining accounts. Maybe I could have done something like CPI context is this, then CPI context remaining accounts is context remaining accounts. Then I wouldn't need all of that stuff. It would have been that easy. Okay. Oh no, it's not that easy. Hold on. You want a vector and you found a reference. Okay, it's still not trivial, but I guess now, like this, it will work. Point of this entire excursion here is knowing more about Anchor really helps you build better. Yeah, then obviously the program, we need to know which program we're calling, and the signer seeds if we want to add signatures for a PDA or for PDAs. If our program signs for something, then we need to provide the seeds. Cool. How do we create such a CPI context? Well, with the CPI new or new with signer, if we want to add signers. And that's pretty simple. We just say which program and which accounts. Then we have the context, which again just corresponds to what we have here. Additionally to the context, we then also need the instruction with the parameters and their account. So the context is just one part. As we will see later when we actually call it, the context is just a part inside the instruction.
Okay, this seems like quite easy. So let's
and
just
then
continue.
we can have more parameters here as well. So it is very similar to this and this, context plus parameters, context plus, in this case we don't have parameters. Again, jumping ahead too much. So new. If we just create a new CPI context, as I said, program and accounts is sufficient. And what that does is it just stores the accounts and the program and keeps the seeds empty and also the remaining.
So let's just copy this, delete, my own Oracle and create another project in Rust, read from Oracle. Let's call it Oracle CPI, Oracle Trust Program Invocations. And like that. Okay, let's continue.
Remaining accounts are empty. Actually, this is a new vector, so actually the cleaner way might be to just append. And then similarly, if we have the new with signer, then we can also provide the seeds, and the signer seeds will just be taken that we provide. And again, remaining accounts is still just a new vector. I should have really read that documentation a month ago. Damn it. Would have made my reference implementation much cleaner. But hey, I can still make a pull request, and I'm gonna. Don't you worry. Look at that. It compiles. I mean, I still need to test it before I publish it, but that's a task for another time. CPI accounts. One of the main things that the CPI context simplifies is that the accounts are now a generic type, and you can pass in any object that adopts the toAccount matters and toAccount infos traits. Cool, so I got that right by reading this. It needs to have both of those traits. And conveniently, if we hashtag derive accounts, if we add that macro, then they already have that. Convenient. So our accounts, those ones, right? The ones that we did here, like the close accounts and the sum accounts, where we said derive accounts, then they will have those toAccount matters and toAccount infos. It's pretty handy because then we can put the sum accounts right into the CPI context or the close accounts. So if we now want to invoke an instruction of another anchor program, when the program is published and it has a crate, then Anchor can generate instruction builders and CPI helpers for you. And we just need to declare it like this with this CPI feature. Now, I would be interested if I have to have it published, because there must be a way how I can just use my local Anchor program and another program references that. And I want to find out how that works. So let's create ourselves yet another Anchor program. GM Anchor. While this is slowly building, simply declare your program's dependency on the program you're calling in your program's cargo toml file as follows. So easy. Path to the callee. So that's the program that we call. I'm the caller, he's the callee. By adding this CPI feature, your program gains access to the callee CPI module, such that we can then do stuff like callee CPI and their instruction. For instance, in the Anchor SPL, in the token, we would have those functions, and the CPI feature enables us to access them. The CPI module exposes all these instructions as a Rust function that takes the arguments, a CPI context, and the additional instruction data.
Okay, so I think I can't do that in the playground, but let's see if I can just... I have contracts here. Let's create another terminal. CD contracts. Contract. And just create an Anchor project. Okay, Anchor is not installed. Then let's install Anchor. So here I should have Rust installed. I have Solana installed. I have Yarn. Anchor. Install AVM, use a cargo. I probably have to sudo. Okay. Just run this. Okay, then just go install Rust. So it looks like we're running like that. Okay then. And proceed with the customer. Proceed. Okay, this will take a few minutes and I can clean the mouse. So. Someone's playing music. Okay, this is taking really long. I wish I had faster internet here. Yeah, but this should be the Rust installation. Solana keygen should have Solana. Yeah, I have Solana keygen, or at least Solana installed. I definitely have Yarn. Yeah. And then install Anchor. And now we should have Cargo, because I think that's what installed Cargo here. Like, I feel not that well. I probably ate something weird. Still downloading, installing. Just is installed, great. Yeah, thank you, Jim. Okay, then. Okay, this works now. Perfect. So far we are just setting up Anchor for a local environment. Until now we just use the playground. Okay, only warnings, but seems fine. Let's drink something. Done. Let's see if this runs now. Probably apt is still not installed. Okay, sudo. So we just use brew instead of hive. Let's just skip it and see if we can still make it work. This would be nice with faster internet. Interesting that the remaining bytes went up. There are tons of packages. Oh man. Is it raining? No. My MacBook is getting like the fan vent just on. So this seems like to be a lot of load. It's a Pro MacBook with the latest M3 chip. Yeah, the fan is on. And it's actually quite hot. It's really hot. Oh, like the panel between the keys and the display is really hot. Like there are the air intakes or outlets, but it's getting really hot. And I definitely ate something wrong. Oh man, I don't feel well. What did I eat? What did I eat? Nothing weird. Okay. Like it says, add this path to your path to be sure to add. Oh, my stomach. Okay, this was a new tab. I think it just ran it. Okay, so now we have Anchor installed. Still using pre-built binary. Okay, that's just another way to install it. Anchor init new workspace. We're using a monorepo, but we don't need the app folder. Like we have different structure. Okay, then let's just run anchor init. Can we just run it without workspace? let's restart VS Code. And open our space. Nope. It's kind of terminal. Okay, here it works now, but we need the let's call the workspace learning. Okay, so it just can just rename this now to let's delete contracts. Rename it to anchor. Yeah. So unfold up. We don't have types in there, but it wants types. Probably because it isn't select anchor build. You're not a workspace. Because I renamed the fucking thing or what? CD anchor. Build. Yeah. That seems better. Seems to create something here. Yeah, perfect. And then we should have types here for our learning thing. Programs. Nope. Programs, new folder, counter. Then create. Okay, let's see how the playground should handle those things for us. Let's just do this video about setting up local Anchor or Solana development environment. Yeah. Um, let's go to is this our counter? This is our counter, and we wanna import. No, this is sharing. This is exporting. Connect to project land. Yeah, let's try and convert it. Anchor build. Okay. Perfect. Let's see what we have downloaded here. Okay, then we should be able to just copy this and paste. The build is still running, what the fuck? It's downloading something. Okay. So programs. Perfect. Okay, we have our counter. Let's just export everything else, then we can move from using the playground to just doing it in our IDE. Solana Dev Learning. That's our actual counter, I think. Yep, this isn't, let's delete it. This isn't our counter. This is our counter. Export, convert and export. So let's open this and programs. Wow. This hasn't worked, or am I dumb? Take the my counter, put it into programs. Replace. I put it into tab. Where the fuck did it move? Ah, okay, I'm just dumb. Then we can delete this one. And it's still building, or what? Can't take that long every time. Like, it builds in seconds in the playground. This can't be right. With project. Is this actually our code? Yeah, awesome. Then export this as well. VS Code. We have our proof project. I hope this works. With just moving the program folders. I hope that's fine. And I'm not destroying anything. Okay, we have our diff, testing PDA reads, no, Oracle, no. My own Oracle, yes, do we have it already? Okay, then let's export our Oracle. Take the program. It's still building, what the fuck? Take the Oracle CPI. That's errors. Oracle CPI. Programs. So we have now our Oracle CPI. It can now actually follow this.
So this is the exact same as we get it into our program context and then all the instruction data. This is the exact same when we now call the CPI. When we call that other program, we also call their function provide the CPI context and the input parameters. Like so, program CPI, then the function, then the
Oh,
context,
already recording
then the
for about an
parameters.
hour.
We don't have any parameters used here.
Okay.
These
Then I will
functions use the same
probably
format as the instruction functions in your Anchor programs, only with
do
the
the rest
CPI
in a
context
new
instead
video.
instead of the context. Yeah. it's as if we just call that other function.
But let's just continue
Hold
watching
on a
the
second.
tutorial.
We
Then I
could
have some
even recursively call
knowledge,
our own program.
at least
Why
some
don't we do
experience, and
that?
heard
Why
some
do I
of the
try
stuff
to build
before.
myself a new
Then
program
going
if
into
I
the
can
next
just
video.
call myself? Because I want to know how to include the new program. Yeah, that's why. I remember. Maybe I let the GM program call itself recursively. By the way, do you see my nice transparent Solana logo? I love green stuff on shirts. It makes perfect sense with a green screen. Okay, perfect. It built. So let's make a GM instruction, and I'm gonna give you one, which is a number, a U8. How many times we say GM, and then we just say GM, and if we still have GMs to say, then we just recursively call the GM instruction again with the same context and
Oh, okay.
one GM
Didn't know it.
pure.
That's how we call
So
it.
that's just a recursive call
Functions
to
over and
GM.
over.
Point of this is I don't need to go through the CPI context if I call an instruction or a function inside my own program. I could, and I don't need to. What's your problem? Result must be used. True story. Oh, right. We're in Rust. You don't like those. So either we call another instruction or we
Oh,
end
nice
it.
though.
Okay, then we need
Something
a
isn't
validator.
isn't good.
Perfect, that compiles. Validator running. Yes. Okay, GM program is deployed. Now let's see how we can call this GM program from our other program. Let's make ourselves a new instruction. How about no accounts? No accounts, no parameters, just call it. What we do here
I
now
have to end the video.
is a CPI.
Oh, I think I ate something that wasn't good.